Hello students, welcome back to yet another session of the chapter sound. So in this session we shall start our discussion with a topic which is called characteristic of sound waves. So around us we hear many sounds. Our ear can distinguish between the sounds that are produced from different sources. How is that possible? These are possible with the help of some characteristic of sound waves. Now today we shall learn about three major characteristics of sound waves by means of which our ear can distinguish the sounds that are produced by different sources. Okay, so the first characteristic that we are going to study is called, number one, is called loudness. Okay, loudness. So we know that some sounds are loud, some sounds are soft sound, or you can say feeble sound, like the engine of an aircraft produces a very loud sound. Okay, and suppose our conversation, a conversation that is going on between two persons, that is a moderate sound. Okay, and the rustling of leaves, that produces a feeble sound. Okay, so what determines the loudness of a sound? So it is basically the amplitude of the sound wave which determines the loudness of a sound. A sound wave which has greater amplitude has loud sound, and a sound which has smaller amplitude has a soft sound. Okay, so here we can say that the amplitude of sound wave determines the loudness of a sound. Okay, now if we want to draw the wave shape, that means a wave shape for a loud sound and a soft sound, how can we draw it? See here, here you see, this is the wave shape of the sound wave that is produced by a source, and there is another source which produces a different wave shape like this. If you see these two waves, there are two waves here, one the solid line, this one, and the other is a dotted one, a dotted curve. Okay, now if you see the solid curve, this one, here the amplitude is more, and for this dotted one, the amplitude, you see, it is less. So we can say that this one is a loud sound and this one, this dotted one, we can say it is the soft sound. Okay, so this is about the first characteristic of sound wave, that is the loudness of sound, which is determined by the amplitude. The next one is your pitch. Number two is called pitch. Pitch generally means what? It means sharpness of a sound. Now, a woman's voice is much sharper than a man's voice. That means the pitch of woman's voice is greater than the pitch of a man's voice. Okay, that means it is more sharp. Clear or not? So what determines the pitch? The frequency of sound. The frequency of sound wave determines the pitch of the sound. Okay, the frequency of the sound wave determines the pitch of the sound. Clear? The sound which has more frequency has greater pitch, and the sound which has less frequency has less pitch. That means it is less sharp. We can say a woman's voice has more pitch than a man's voice. That means a man's voice is generally flat, or you can say grave. Okay, but the woman's voice has a greater pitch, shrill. It is more shrill. Clear? So let us see the wave shape now. If you see here, this one, if you see, here you see, this is the wave shape of a sound that is produced by a certain source, and this dotted line, or let me draw it separately. This one. If you see these two, here you see the number of oscillation is more, but here the number of oscillation is less. So this one is a high pitched sound because the frequency is more. This is a high pitched sound, and this one is low pitched sound. Okay, I hope you understood the wave shape. Which has more oscillation, which has more frequency, will have a greater pitch. That means the sound will be more sharp, and which has less number of oscillation, that means which has low frequency, has less pitch. Okay, that means the sound is less sharp. Clear? The third one is called, the third characteristic is called quality, or we can also say this as timbre. Okay, it helps us to distinguish. It helps us to distinguish between two sounds having same loudness and pitch. Now take for example the sound produced by musical instruments, suppose a sitar and a guitar. Okay, both have the same loudness, both have the same pitch, but you can distinguish, without seeing you can distinguish which one is the sound of a sitar and which one is the sound of a guitar. How is that possible? It is possible with the help of the quality of sound that it emits. Okay, so this one you will understand better when you will go to the higher classes. That means what? Though the sound have same loudness and same pitch, the sound that is produced are the mixture of many frequencies. Okay, that is not a single frequency. A single frequency, a sound which has a single frequency is called a tone. Okay, single frequency sound is called single frequency sound is called tone. Okay, but the musical instruments emit sounds which is a mixture of many frequencies, like first fundamental tone, first overtone, second overtone, third overtone. In that way, there are different frequencies which mix together. Then when these frequencies mix together, there is a relative intensity, there is a relative change in their loudness or intensities. Okay, and with that only we can determine two sounds between we can distinguish, sorry, not determine, we can distinguish between two sounds emitted from two different musical instruments. So single frequency sound is called a tone. Mixture of frequencies, mixture of many frequencies is called note. Okay, so here you can write two sounds having same loudness and frequency same loudness and pitch can be distinguished by the relative intensity, of their harmonics. Harmonics means the higher frequencies. There is a basic frequency which is called the fundamental frequency, and there are more frequencies, higher frequencies, which are called harmonics. So these harmonics, their intensities are different for different musical instruments. Okay, and this is only the thing that helps us to determine between two sounds emitted, not determine, distinguish between two sounds emitted from two different musical instruments. Okay, so you can also write example: sound of a sitar and a guitar can be distinguished by its quality. That means if the sound have the same loudness, same pitch, then they can be distinguished from each other by its what? Quality. Quality means the relative intensity of their higher frequencies. Okay, these things will be more clear in your higher classes. Okay. Okay, now we'll discuss about two terms. One is called intensity and the other is called loudness. Both these two terms seems to be same. Like intensity, that means the sound is more intense. We can say that the sound is more loud. Okay, but these two are different things. You might say that these two are same. Yes, these two are somewhat they are similar, but there is a difference between them. There is a difference between intensity and loudness. Now what is intensity? What is the difference between intensity and loudness? First one is the definition of intensity. It is the amount of sound energy. It is the amount of sound energy that crosses a unit area per unit time. That means the energy, sound is basically energy. We know that how much energy crosses a unit area. Unit area means 1 meter square area or 1 centimeter square area. How much energy will normally cross through it in unit time. Per unit time, how much energy is crossing that unit area. That is called intensity of sound. And for sound, for loudness, it is the response. It is the response of the ear to a sound. Loudness actually means what? It is a feeling. We can say it is a feel. Okay, that means how much means just think that someone is playing a loud music. For that person who is playing that loud music, he is enjoying it, but you are not enjoying it. You are finding it like it is creating some kind of noise pollution. So for him, that response is nice. The response to the ear for that person is nice who is playing that loud music, but for you, that response is not very pleasant. Okay, so in the loudness, that means the response for him is good. The sound is not unpleasant for him, but for you, it will become a noise. Understood? So it is the response, generally a response to the ear. How our ear respond to that sound. For some, it might be loud, it might be unpleasant, and for some, it might be pleasant. It might be okay for them. Clear? So this is the response to the ear. So number 2 is it can be measured. That means it has a value. It can be measured. And since this is just a response, it is just a response of the ear, it cannot be measured. We just can feel it. We can just feel it. It does not have any value, but it will have a value. Okay. Then number 3, its unit is decibel. D-E-C-I-B-E-L. Decibel. Decibel is the unit of the intensity of sound. And since this one cannot be measured, so there is no question of it having any unit. So it has no unit. It is just a feel. Here it is just a feel. Okay. Okay, so let us finish the session with a numerical related to the chapter sound. Okay, here you see, calculate the wavelength of sound wave whose frequency is 220 Hz and speed 440 meter per second in a given medium. This is an in-text question of page number 166 of your NCERT book. So how to solve this? So here you see the frequency is given u, which is equal to 220 Hz. The speed of sound is given, which is 440 meter per second. Okay, we need to find out the wavelength. So we know the relation, we have derived it earlier, which is velocity is frequency into wavelength. So wavelength will be equal to velocity divided by frequency, which is, what is the velocity? It is 440, and what is the frequency? It is 220 hertz. Okay, so this one cancel, it will be 2. So the wavelength of the sound wave is 2 meter. Okay, there are more questions. You can do question number 4. This one is question number 3. You try by yourself question number 4, and there are some questions in the exercise also, which I will tell you later on which one you have to do. Clear? So with this I end today's session. Thank you.